Hello, this presentation is on UML Communication Diagrams as part of the CS 364 Software Engineering course and is presented by Todd Anderson and Adam Tipton. Hi, my name is Adam. What exactly is a UML Communication Diagram? A UML Communication Diagram, formerly known as a collaboration diagram in previous UML versions, is a presentation of data that shows how certain objects interact with one another and perform particular use case behaviors. By using this tool, designers can more effectively communicate object definitions, roles, and the flow of events of a particular use case. The communication diagram contains three major elements. The first element is the frame, a rectangular box where all of the other parts and elements of the diagram will live. In the upper left-hand corner of the frame will be a compartment housing the name of the diagram. It should be noted that there is no long or short form standardization of the name or heading, but for this example, I've named it interaction, do something. Feel free to name yours, whatever makes the most sense for your use case. The second element is called the lifeline, not to be confused with the dotted line of a collaboration lifeline. Shown as a rectangle, a communication lifeline represents a single participatory entity in the interaction. There are several ways to title a communication lifeline. Generally, the lifeline will be formatted with a colon and then a class name. This example shows an anonymous lifeline with a finder class, or in other words, an unnamed instance of the finder class. The lifeline name will precede the colon and class name. Shown is lifeline seeker of class finder. The last element is the message. An arrow will define the direction of the message. In this example, the message is traveling from the left and flowing towards the right. In this example from umldiagrams.org, if S1 equals S2, an instance of anonymous class A will send a remove method message to an instance of anonymous class B. In the message definition, you will notice a particular format, sequence expression, sequence term, colon, and the message name. The decimal 1.2.4 is the sequence expression in sequential order. For example, expression 1.2.5 or even 1.3 would be next in a concurrent thread. An additional message would have a new number, 2 in this case, or if it is a parallel message, we could add a letter to it like 1A or 1B, and this isn't shown. Inside the square brackets is the terms S1 equals S2, which is followed by the colon and a message remove. The arrow indicates the direction of the message flow from A to B. If S1 equals S2, then class A sends a remove method message to class B. When we speak of notations, we are generally speaking of objects, actors, links, and messages with their numbering. As we've already covered objects and messages in previous slides, we will focus on actors and links. An actor, which has a name and a role, is an invoker of an interaction. In order to keep a diagram simple, it is recommended to keep actors to a minimum. However, if more than one is necessary, keep them off to the side as not to clutter up the diagram. Generally, the symbol for an actor is your basic stick figure. However, it could be something else if appropriate. The actor's name is located directly underneath. In this example, the actor's name and role is customer, or an unnamed instance of the class customer. In close association with messages, we have links, which connect actors and objects together. Relationship links allow messages to be passed between objects. They are usually illustrated as a solid black line that connects two entities. If we refer back to the previous message example, you'll see the solid black line running from object A to B. Notice the black arrow, which represents a message directly above it. Putting it all together in a somewhat silly example, you can see a simplified way of assembling a quick communication diagram. If bored, the actor will send an amaze me message to class, which in turn sends a sequence message to Amazifier to do something amazing. Once complete, the Amazifier starts a new sequence, sending a message back toward the anonymous class stating that it did something amazing. Although this diagram serves its purpose well, it is left as an exercise for the student to delve deeper into all of the variables of a communication diagram. However, you now know enough to immediately start your own simple communication diagram.
For an example, let's consider the interactions required for a customer to make purchase at a fast food restaurant. How does a restaurant handle communication from the point at which a customer orders till they receive their food? Basic steps required to meet this example is first, the customer must talk to the cashier. The cashier takes the order, places it into the system. The workers can then process the order. At the same time, the cashier must take some form of payment from the customer. Once both of these lines of communication or these interactions are complete, then the customer is finally able to receive their food. To relate this to a UML communication diagram, let's get more into the components required to understand and to map this out. We see the customer send an order to Sue, who belongs to the worker class. Sue is the cashier. Sue takes the order and then places it onto the register. Once the register receives the order, then it goes to display the order to Bob, who belongs to the worker class as well. Bob is then able to provide the customer with the order that they had. Let's take the UML communication diagram to the next level. In order to apply it to our food application, here is one example of an interaction we can have. This relies upon the filter and sort mechanisms in the app. We begin with the user who wants to search for a recipe, and then that will take us to the hub, the search and filter object. This object will control the rest of the process. From here we move to 1.1. We filter the search and look through our database to see if we are able to find any kind of a result. In 1.2, we see a bracket has result close bracket. This indicates that if this has result is true, then we will continue with 1.2, which will then retrieve the results. So we're only going to go into our database and retrieve the information if our select query returns a positive value. From then on, we move to a sort function and then to a display results function.
Although a communication diagram is not always necessary, it has several benefits. It can help to clarify a sequence diagram. It gives a visual representation of a use case. It clarifies entities, objects, and interactions of a use case in a system design. It effectively communicates the purpose of objects, links, messages, and selectors of a use case. Even though the communication diagram can be a great tool for clarifying a design, like all UML diagrams, it may not necessarily be helpful to create one. For example, a formal diagram is not necessarily needed. A lot of what a communications diagram can do can easily be communicated with hasty doodles on a whiteboard, especially if the design is simple. It can be a bit complex and overkill in certain situations, especially with simple designs. It can also be a bit time-consuming to learn the notation and to then implement its rules. Here are a few recommendations as to when a communication diagram would be appropriate. 1. When you want to model message passing between objects or roles in a use case. 2. When a model would clarify the design of an architectural design system. 3. When you'd need to capture certain interactions, such as message passing between objects and roles in a use case. 4. When you'd want to model multiple alternative solutions to a particular use case. 5. When you'd want to further define and clarify objects, attributes, and activities of a certain use case. 6. Use a communication diagram only when it is necessary or beneficial to your purpose. Avoid overkill.